You've already mastered the art of importing all types of single files in Python. Congratulations! However, to earn your daily bread and butter as a data scientist, you'll be required to interact with more complex data structures, such as relational databases. Now, what is a relational database? It's a type of database that is based upon the relational model of data, first described by Ted Codd in the late 1960s. Before getting too theoretical, however, let's check out an illuminating example, the Northwind Traders database, a synthetic database that contains sales data for a fictitious company. Firstly, a database consists of tables. Here you can see 3 tables from the Northwind database: orders, customers, and employees. So what's a table? A table generally represents one entity type, such as order. Notice that this table looks a great deal like a data frame, and that's the point. In a relational database table, each row or record represents an instance of the entity type. In this case, each row is an order. Each column represents an attribute of each instance, such as the order date in the case of orders. In this sense, a table is entirely analogous to a data frame. It is essential that each row contain a unique identifier, known as a primary key, that we can use to explicitly access the row in question. In our orders table, you can see that the key is order ID, the first column. But recall that a database consists of many tables. The really cool thing about relational databases is not merely that you have a bunch of tables, but that the tables are linked. Now, how this linking works is ultra intuitive. See that the orders table has both a column called customer ID and one called employee ID. These columns correspond precisely to the primary keys in the customers and employees tables, respectively. So, given an order, you can immediately look up the details of the relevant customer or employee. This is super cool because it means that you don't need to store all the customer details such as first name, last name, company with every order that they place. You merely need to look it up in the customers table. This saves an incredible amount of space. As stated earlier, the relational model was originally proposed by Ted Codd and has been widely adopted. There's a great deal to the theory, but it's most neatly summarized in Codd's 12 rules, also known as Codd's 12 commandments, which he developed in the early 1980s to combat what he viewed as a dilution of his original relational database vision. Codd's 12 rules actually consist of 13 rules, but they're zero index. That is, the first rule is labeled 0. If this makes you laugh, you're definitely a geek like me. These 13 rules were defined to describe what a relational database management system should adhere to in order to be considered relational. Among the most popular of such systems currently are PostgreSQL, commonly called Postgres, MySQL, and SQLite, all of which use the SQL query language. In fact, SQL itself is actually an acronym for Structured Query Language, which describes how you communicate with a database in order to both access and update the information it contains. The term querying is really just a fancy way of saying getting data out from the database. Next up, you'll learn how to connect to databases, but before that, let's make sure that you have a solid conceptual grip on the relational model. All right, we're back. What we really want to do is to get our data out of our database using SQL, or the structured query language. But before we get to that, we're going to need to figure out how to connect to a database. We'll use a SQLite database as an example because SQLite is fast and simple while still containing enough functionality to introduce you to all the necessary concepts of querying a database. There are times when you would prefer to use Postgres or MySQL, but for our purposes here, an introduction to interacting with relational databases in Python, a SQLite database is perfect. We'll once again look at the Northwind database. There are many packages we could use to access a SQLite database, such as h33 and SQL Alchemy. We'll use SQL Alchemy as it works with many other relational database management systems, such as Postgres and MySQL. So without further ado, to connect to northwind.sqlite, we need to import the relevant function createEngine from the package SQL Alchemy. We then use the function createEngine to fire up a SQL engine that will communicate our queries to the database. The only required argument of createEngine is a string that indicates the type of database you're connecting to and the name of the database. Next, in order to query the database, we need to connect to the engine to do so. But before we do this, we would like to know the names of the tables the database contains. To do so, apply the method tableNames to the object engine. This will return a list of the table names that you can then print to the console. Now it's your turn to do the same. Fire up that database engine and print out those table names. After this, I'll be back to show you how to connect to the engine, how to query your databases, and then you'll get loads of practice writing your own queries to import data from relational databases. Now that you've figured out how to create a database engine and to list the tables of the database in question, it's time to connect to the engine and to query the database. Once again, the term querying is just a fancy way of saying getting data out from the database. The hello world of SQL queries is select star from table name, where table name is the name of any of the tables in the database. This query returns all columns of all rows of the table of interest. For example, I could query the Northwind database with select star from orders, and this would return all columns of all rows of the orders table. The star after select means all columns. Straightforward, right? Well, nearly. This is an SQL query, and we need to figure out how to make such a query using Python, SQL Alchemy, and, in fact, we'll also use pandas to store the results of our queries. The workflow will be as follows. You'll import the required packages and functions, create the engine, connect to it, query the database, save the results of the query to a data frame, and then you'll close the connection. Let's now check out how to do each of these steps. Create the engine using the function createEngine. To connect to the database after creating the engine, you create a connection object con by applying the method connect to the engine. To query the database, apply the method execute to the connection con and pass it a single argument, the relevant SQL query. This creates a SQL Alchemy results object, which we assign to the variable rs. To turn the results object rs into a data frame, we apply the method fetchAll to rs and save it as a data frame using the pandas function dataFrame. FetchAll fetches all rows as you would expect. To close the connection, execute con.close. Don't forget to do this. You can then print the head of the data frame, as we have done before, as a sanity check. All the rows look good, but the column names aren't quite correct. To fix this, before closing the connection, you can set the data frame's column names by executing df.columns is equal to rs.keys. One last note. Analogous to what you saw in Chapter 1 when opening plain text files, you can use the context manager construct to open a connection, which will save you the trouble of closing the connection later, or save you the trouble of forgetting to close it. There are two other differences that you may have noticed between this and the previous code. Firstly, I no longer have select star in the SQL query. I now have column names of the table orders. All this does is it imports those particular columns and no others, whereas select star imports all columns. Secondly, instead of applying the method fetchAll to the results rs, I apply the method fetchMany with the argument size equal to 5. This imports 5 rows instead of all rows. You'll become better acquainted with these functions and arguments very soon. Now that's enough out of me. It's time for you to practice writing your own SQL queries and to import data from your database. Enjoy. By now, you've become familiar with querying individual tables of databases, such as the orders table of the Northwind database. You'll remember, however, that much of the power of relational databases stems from the fact that they can capture relations between tables. The tables are linked. For example, as we saw earlier, the orders table of the Northwind Traders database has both a column called Customer ID and one called Employee ID, columns which correspond precisely to the primary keys in the Customers and Employees tables, respectively. This means that, given an order, you can immediately look up the details of the relevant customer or employee in the appropriate table. Now, what if you want to incorporate such information into your query? For example, if you want to query the orders table and include for each order information about the corresponding customer from the customers table. A specific illustrative example will go a long way here. Let's say that we wanted for each order to get the order ID and the company name of the customer. The order ID lives in the orders table, while the company name lives in the customers table. SQL has a really clever way of doing this. It's called a join, because what you're really doing is joining two tables together. In this case, the orders table and the customers table. Specifically, it's an inner join. There are also other types of joins which we won't cover in this course. As it's the customer ID columns of the orders and customer tables that correspond to each, you'll want to join the tables on these columns, and that is precisely what I've done in this code. The notation of dot followed by column name is merely selecting a column of a table. The table that we are selecting from is orders inner join customers on orders.customer_ID equals customers.customer_ID. And I am selecting the order ID column and the company name column of this new table. I know that that's a bit to take in, but after you get your hands dirty performing some of your very own inner joins, you'll be far more comfortable with this advanced querying technique. It's your turn to query. Congratulations on doing so well in a crash course on relational databases. Whether you've seen them before or not, you're now able to create engines and connect to them in Python, perform simple select queries, filter your results using where, perform more complex queries such as join and store all your querying results in pandas data frames, among many other things. These skills will get you a long way in using Python to import data from relational databases. In fact, having made it through this course, you are now well equipped to import all types of files in Python, from plain text to flat files, Excel to MATLAB, among many others. Well done. But that does not mean there's not more to be learnt. What about importing data from the web, where so much of it is stored? In the sequel to this course, you'll learn how to import web data. It's a short course and will equip you to import data from the World Wide Web and pull data from application programming interfaces, also known as APIs. You'll take a deep dive into the Twitter streaming API, which allows us to stream real-time tweets. I'm sure that you're itching to get your hands dirty with web data, so I'll see you in the next course. You've seen that, after creating a database engine, you can get the results of any particular query using only 4 lines of code: connecting, executing the query, passing the results to a data frame, and naming the columns. 4 lines of code is pretty good, but you can do even better. You can actually do it in 1 line, utilizing the pandas function read SQL query and passing it 2 arguments. The first argument will be the query you wish to make. The second argument, the engine you want to connect to. And thus you can achieve the same as this code by executing this single line. The power of pandas. In the following exercises, you'll gain more expertise in writing SQL queries and using pandas to execute them. What are you waiting for? The end of this video? Let's do it.